This is polarizing film from the Polaroid company. It's a trade secret as to what it actually is, but some studies of it show that it seems to be some long-chain polymers, which are proteins that have been stretched and stretched and stretched until there's a very fine lines of openings, sort of like the openings on the rack from the oven. And so you see here is there's white light reflecting off of this paper, and then when it goes through this film, well, it's sort of grayed out. So what does that mean? Well, that means that the light that's bouncing off the paper is being randomly polarized. It's vibrating in all different directions, heading up towards the camera. But when it passes through the filter here, only the vibrations that are up and down, let's say, for example, are passing through, meaning that's filtering out all the other ones, and we're polarizing the light. This is how we know that light is a transverse wave, because only transverse waves can be polarized. Now here's a second polarizing filter, and if I put one in front of the other, well, it gets a little bit darker, which means that, well, maybe right now, a lot of the light coming through is up and down. There might still be a couple of other side-by-side vibrations coming through. But when I put a second filter in the way, it filters out more of it, so it gets even darker. But watch what happens instead when I take this filter and turn it 90 degrees. Oh, look how dark that gets. So what's happening? Well, right now, if this filter, for example, is only allowing up and down vibrations through, and I take this filter, which is also allowing up and down vibrations through, but I turn it 90 degrees, now it only lets through side-by-side vibrations. So if only up and down vibrations are getting through here, how much of that is vibrating side-by-side? Well, none. And so this should effectively filter out all of the light.